Hint number 2. We need to transform the dm's into dx's. Now recall, regular density is equal to mass divided by volume. Linear mass density is equal to mass divided by length. If we rearrange that and solve that for mass, mass would equal linear mass density times the length. But this statement here is only true if the linear mass density is constant throughout the whole shebang length. But in this problem, it changes. It changes as a function of x. So this part of the rod doesn't have the same linear mass density as this part here. Each dm is going to have its own unique linear mass density value. So what we can say is that, dm is equal to lambda times dl. If dl is small enough, then lambda would be constant over that dl, and then we could multiply lambda times dl to get the small amount of mass, dm. And in this particular case, we know that lambda is a function of x, so I could put in 2 times x, and dl could also be called a piece of the x-axis, so we could also call that dx. So this time we're going to transform dm's into dx's using the fact that each little dm, each dm up here, corresponds to a little change in the length dx. And this is how to transform between dm and dx.